So in this video, I'm going to show you how to find the area to the right of a z value. Alright, so let's get started. Alright, in this first example here, find the area to the right of negative 1.25. Now it's very important that we draw a picture and shade the area that this example is referring to. So let me draw a bell curve. Of course, we have our z equals 0. That represents the mean. 1 standard deviation above the mean, 2 standard deviations above the mean, 1 standard deviation below the mean, 2 standard deviations below the mean. Now, where is negative 1.25? It has to be between negative 1 and negative 2. So I'm just going to mark a spot here. Let's just say it's right here. Now, what part should we shade? Now, this example says find the area to the right. Right is the operative word here. So, right of this number here, which is negative 1.25, would be this area. So, notice that we are shading more than half or more than 50% of this bell curve. So our answer would definitely be more than 0.5. Alright? Now, the dilemma is that the standard normal distribution, the z-table, only gives us the area that's over here. But we want the area that's over here. So let me put z-table here. The z-table will give me the value that's over here. Let's go ahead and find that value that's over here, although it's not our answer. It will help us to get our answer. So if we look at our table, and I want you to find your table, we're going to look for a negative 1.25. Of course, we should be on the negative side, right? Here's negative 1.2. And 0.05 is here, so the intersection of these two would be this, 0.156. So the area that is here is 0.1056. So that represents the area to the left, this part here. This is the area to the left of our z. How do you think we should find, using this information, find the area to the right? Well, since everything under this bell curve is 100%, then we also know that everything under here, because we're dealing with probability, should equal to 1. So the total area under here is 1 or 100%. So since we're dealing with decimals, so notice that we have decimals in our z-table, we're going to subtract this value 0.1056 from 1, since the total area under here must equal to 1. So let's do that. Alright, 1 minus 0.1056 equals to 0.8944. So therefore, the area to the right, which makes sense, right? Because we knew it had to be more than 50%, is 0.8944. Or 89.44%. Alright, here are some things to remember. Remember that although values of z can be negative, probabilities or areas can never be negative. So remember that although values of z can be negative, for example, that negative 1.25, So these definitely can be negative to z's. Probabilities or areas can never be negative. And also another tip, all the area, everything under the area should equal, under this bell curve should equal to 100% or 1. So probabilities would never be greater than 1 or less than 0. Alright, let's go on to the next example. So let's say I make up a z value if we don't have another example, right? So let's say I give you this one. Let me make up an extra problem here. Find the area to the right of negative 1.17. So the first thing I want you to do, I always do, I want you to draw a picture and shade the area. So in this section, in this chapter, I want you to draw a picture for mostly everything and shade. So if I draw a picture here, and I know that 0 is here, 1 is here, negative 1 is here, negative 2 is here. Again, I know that negative 1.17 is somewhere between negative 1 and negative 2. And we're trying to find the area to the right. So again, I know that it's going to be more than 50% because look at all that's being shaded. It's definitely taking up more than half of this bell curve. Alright? So we first start with our table, but again, our dilemma, the table will only tell us the area to the left of this negative 1.17. But we need that to figure out the area to the right. So we don't get frustrated. We just find negative 1.17 and we find our 0.07, which is here. And we find the intersection of those two numbers. So what we get is that the area to the left is 0.1210. That's the area that's to the left. However, since we want to know the area that's to the right, what should we do with this value 0.1210? We should subtract it from 1. So we're going to go 1 minus 1210. 1 minus 0.1210. Again, probabilities will never be more than 1 or less than 0. I want you to put that in your calculator. And you should get something like 0.879. And always, for probabilities and areas, let's go 4 decimal places. So I'm going to add a 0 here. So 4 decimal places for the probabilities and the areas. For the z-scores, I want you to always round to 2 decimal places. Hundredths place for the z-scores and 10,000ths place for the probabilities and areas. So here we have 0.8790 will be this area over here, or as a percent, 87.90%. Alright, this concludes my video on how to find the area to the right of a specified z.